I take the recording for you.
Oh, sorry.
Oh, I say I start the recording.
Oh, thank you. All right, let's get started. Uh, thanks for everyone. Today I'm going to show about the latest Curve stablecoin, and I'll try to introduce it at a high level. So maybe make it simple, will not be too technical, and let's get started. Because Curve community loves llama. I don't know why. Uh, so this picture is a llama, and they have an AMM called llama. And firstly, I will introduce the problems of the current protocols. Currently, the lending or stablecoin protocols, they will use liquidation to maintain healthy. And this, I think this also includes Perp v2 because we use multi-collateral. We also need to liquidate users' collateral when they're underwater. So liquidation is important to keep the protocol healthy. And normally the liquidation process is like this process. Uh, when the collateral price goes down, so liquidation will happen, and liquidators will help users to repay their debts. Normally, users will have debt on the protocol, and when their collateral price goes down, liquidators will help to repay the debt. And the protocol will sell part of the user's collateral to liquidators at a discounted price. And normally liquidators will sell those collaterals to DEX and CXs because normally they don't want to hold those collaterals because the collateral may be altcoin and liquidators may only hold stable coins. And liquidators will also use something like flash loan. So they have to sell those collaterals in a single transaction to pay the flash loan. And this is an example of liquidation happens on lending or stablecoin protocols. Let's say the ETH current price is 1,000, a user deposit 10 ETH and minted 85,000 USD. So he has 85,000 USD debt. And let's assume the liquidation price is at 900. So when the price goes down to 900 at this price, when the price goes down to 900, sorry, to this way, liquidators will join to liquidate the user's collateral. Normally, they will not liquidate all the collateral. Maybe, for example, in this example, liquidators only liquidate 50% of the collaterals. So liquidators can buy 5 ETH from the protocol, actually from the user at a discounted price. So the price is 900, but liquidators can buy at 810 and help the users to repay his debt. After this liquidation, the user the user's health ratio may become higher, and the next liquidation will be lower. So maybe the next liquidation price is 850. And if the price continues goes down, there will be a next liquidation. Maybe this time liquidators will liquidate another 50% of the collateral. And if the price continues goes down, maybe the liquidators will liquidate all the collateral of the user. So when the price hit the liquidate threshold, liquidators will liquidate part of the user's collateral. And if the price continue going down, liquidators finally will liquidate all the collaterals. And problem of this design is that if a big well being liquidated, huge amount of collaterals will be sold. And liquidators will get these collaterals, and normally they will sold to the market. And this will cause market fluctuations. And because they liquidators sell those collaterals, and you will cause further price drop and cascade liquidations. So the price continues to drop, and other users will go liquidated. And if because liquidators normally will sell those collaterals to maybe DEXs or SEXs, so you will rely on the liquidity of DEX. So if there's not enough liquidity on DEXs, you cause the bad debt on the protocol. And if users got liquidated, users will have a permanent loss. So just as this example shows, if the price hit this liquidation threshold, users will go liquidated. Even if the price went back, the user's loss cannot be recovered, and it's a permanent loss. You will lose some of your collateral, and even if the price goes back. Yeah. So this is the problems of the current protocols. And there's a link that it actually happens, I think 2 or 3 weeks ago. Aave got some well got liquidated on Aave, and there's a bad debt happened. The Mongo market exploiter, he borrowed 92 million of CRV, and he wants to short CRV because he wants to liquidate Michael, the creator of Curve protocol. But he failed, so he got liquidated. And no matter who got liquidated, even Michael got liquidated, or this person got liquidated, the victim will be Aave protocol, because there is a highly possibility that Aave will be in bad debt after liquidated. As this article says, CRV liquidity is not enough. And it took 15 minutes to liquidate all these positions, and there's a bad debt left in Aave. So this is the problem of current protocols, including lending and stablecoin. And the goals of Curve stablecoin is the first one is we don't want to rely on external DEXs, because liquidities on these DEXs or SEXs is out of our control. And the second one is reduce users' loss. As we mentioned, user will have a permanent loss when they're being liquidated. So we want to reduce users' loss when liquidation happens. The third one is gradually liquidate users' collateral. In the last example, there are 3 liquidation events. So maybe the first time liquidator liquidate 50% is 5 ETH, and maybe second time he will liquidate 3 ETH, and the last time liquidators will liquidate 2 ETH. So only 3 times this user only deposit 10 ETH, and if this user is a big well, and he has maybe 10,000 ETH, it will be a problem if we only liquidate 3 times. So there is a lot of ETH will be dumped to the market. So our goal is to gradually liquidate users' collateral and convert them back when the price bounces. So I'll take this example. Our goal is when the price hit the liquidation threshold, we started to liquidate users' collateral and gradually. And if the price goes back, we will, when liquidation happens, we convert users' collateral to stablecoin, maybe ETH to USD. ETH to USD. So we'll gradually liquidate users' collateral. And if the price went back, we will convert back the tokens. So USD will be converted to ETH. So if the price goes back, it will reduce users' loss because your collateral is converted back. All right. And the solution is this Curve stablecoin. They have several parts in the design. The core part is this called Llama, lending liquidation AMM algorithm. I think this name is just for fun for me because it's similar to Llama. And Curve community loves Llama. So this is AMM. They have AMM, built-in AMM in this stablecoin, and they have a controller that controls the borrowing rate, and the users deposit through this controller, deposit collaterals through this controller. And for this part, the peg keeper and monetary policy are used to stabilize the price of the stablecoin. Let's call this stablecoin Curve USD. So this part is to stabilize the price of Curve USD. And this is before and after. Before, Curve USD is painful when user got liquidated, and after that, users will be happy. So let's introduce Llama because this is the most important part of the Curve stablecoin. What is Llama? Llama is an AMM similar to Uniswap v3. So it also has concentrated liquidity, but the difference is that user cannot arbitrarily select a range to add liquidity. Users can only add liquidity through the controller. So the range is selected by the controller. And Curve stablecoin will use Llama for liquidation. So all the liquidation will happen in this Llama AMM. They have a pool. If they use ETH for collateral, they will have a pool on this Llama. Maybe if you use ETH as collateral, there's a pool of ETH and Curve USD. So all the liquidation will happen in this pool. So we don't need to rely on external liquidities to liquidate users' collateral. So Llama's main purpose is to liquidate users' collateral. And users' collateral are deposited to Llama pool. When let's say we use ETH as collateral, if the ETH price drops to a certain price, user collateral will start to be liquidated. And in this Llama pool, users collateral will be converted to USD, and vice versa when price increases. This is what I said, just will convert back to USD if the price goes up, sorry. So what's the difference between Llama and Uniswap v3? The main difference, I think, is the pool reserve changes. In Uniswap v3, this is a Uniswap v3 range, and it has a lower price and upper price of the range. And if the current price is out of the range, let's say the current price is greater than the upper price, like the current price is here. So the pool will be all in USD, right? And if the price goes down, the USD in the pool will decrease and finally become all in ETH. So this is the Uniswap v3 style pool. The difference of Llama is that when the price is out of the range, let's say greater than this liquidation begin price, out of the range, all the liquidity in this pool is all ETH. So it's different, right? At higher price, the tokens are all ETH in the pool, in this range. And if the price goes down, the ETH will be converted to all USD. So this is the liquidation process. So with the price goes down, users' collateral ETH token will be converted to USD. And at this liquidation end price, all your ETH will be converted to USD. So there's no risk for the protocol. If this USD amount is greater than your debt, so the protocol will be healthy and the risk is low for the protocol. And if the price goes back, the USD will be converted back to ETH. So you still have your collateral, but you may have the same amount as you deposited. It may be less, but you still have some of the collateral. So the loss is, I think the loss is less than lending protocol or other stablecoin protocols. So this is the major difference between Uniswap v3 and Llama. And how do Llama achieve this goal? Because it's quite different from Uniswap v3 or other AMMs like Uniswap v2. When price goes down, no matter in Uniswap v3 or v2, the pool reserves start converting to ETH. Yeah. When the price goes up, pool reserves starting to convert to USD. But in Llama, it's different. How do they achieve this? They use a dynamic range and market price. This is a picture from their white paper. Llama will rely on external prices. So there's an external oracle, and they can get the external price from the oracle. And they'll define upper and lower price on external price. They call it P up and P down. Like this chart, P up and P down. So P up is the liquidation price, starting liquidation begin price, and P down is the liquidation end price. So if the price hit P up, your collateral will start to be liquidated until P down. All your collateral will be converted to USD. And if the price goes up to P up, all the USD will be converted back to ETH. So the difference is that this PCD means current down price. So this is the range lower price of this range. And PCU is the upper price of this range. So you can see the range price and the y-axis is the AMM price, x-axis is the external price. So you can see with external price increasing, the AMM price also increasing, and with an increase more faster, or the PCU is increasing and PCD is increasing and more faster. So because the PCD increase more faster at P down, it is lower than the external price. But at P up, this PCD will equal to the up external price. So at this point, external price equals to P up. The PCD will be the lower bound, and external price is at lower bound. This is the same situation of Uniswap. Let's expand this. So at lower price, all your collateral will be ETH, right? So this is the same situation. At this point, the external price will be at this range lower price. So all your collateral will be ETH. And if the price continues goes down, this range will be out of the range, and all your reserves in this range will be ETH. And with the price decreasing, PCD and PCU also decreasing. And you can see at this P down here, the PCU actually equals to external price. So at this point, the range upper price is equal to external price. So it's similar as Uniswap at this point. So external price is at upper range, your upper price of the range. So all your reserves will be USD. They achieve this through a dynamic range and a market price. The market price will also increase with the external price increasing and increase more faster. So as I said, Llama needs to AMM range price changes with external price and growing or dropping more faster than external price. Thus, Llama intentionally create an arbitrage opportunity in contrast with Uniswap v3. So, for example, if let's say the red line is the market price of this range. So if let's say we started here, external price is equal to the market price. So there is no arbitrage opportunity because external price is equal to your market price in the pool. But with the external price increasing in the blue line increasing, and we increase it to here. At this point, external price increasing, the red line is increasing more faster, so the market price will higher than external price, right? So there will be an arbitrage opportunity. So arbitrage, because this price is ETH price, because the ETH price in the pool is higher than external price, so arbitrageurs will dump their ETH to the pool. So the pool will get ETH. So with the price increasing, the pool will accumulate more ETH. And until this P up, all the tokens in the pools are ETH. And the same applies to if the price goes down. If the price goes down, let's say price goes down to here, and you can see the external price is here and the market price is lower. So if the price goes down, market price will be lower than external price. So there will be another arbitrage opportunity because the ETH price is lower in this market. So arbitrageurs will buy ETH from the pool. So they will send their USD to the pool and buy ETH from it. So with the price going down, the pool reserves will be converted to USD. So all this achieved by arbitrageurs. And it's different from Uniswap because Uniswap market price won't change. Let's say we started at this point. Uniswap price is at this P equals to external price. Let's say in Uniswap, in the beginning, Uniswap price equals to external price. If the PO goes up, and external price will be higher than market price in Uniswap. But in Llama, it's different. In Llama, the market price is actually higher than external price because it goes up with the external price and goes increasing more faster. So this is the difference between Llama and Uniswap. So in Uniswap, arbitrageurs will buy ETH from the pool, but in Llama, arbitrageurs will sell ETH to the pool. So the pool token reserve changes differently from Uniswap. And they intentionally design in this way to make the pool being the liquidator, I think. Yeah, because swapping is liquidating users' collateral. And there's a chat we can play. And here we have 3 bands. Curve stablecoin call these bands. So each band has in the x-axis is the external price. So each band has a lower and upper external price, which we call the P up and P down. So this is P down in the band 1 and P up in the band 1. And this also be the P down in band 2 and P up in band 2. And P down in band 3, P up in band 3. And this green, orange, and purple lines are the range prices in the pool. With the blue line, let's assume the y-axis is the AMM price. With the blue line, AMM price will be equal to external price. So you can see the upper range price and the lower range price goes more faster than the blue line. So the upper price and the lower price will be growing faster than external prices. This also applies to market price. So at this point, the upper price is equal to external price. But with the price increasing, the lower price will be equal to the external price. And for band 2, it's the upper price of band 2 equal to the external price. And with price continue growing, the lower price of band 2 will be equal to the external price. And the same applies to band 3. Is there any questions for this design? Did you?
Can you go back? Yeah, this chart. I am trying to understand what does the black line means here. Because I understand that the blue line means where the price of AMM equal to the price of external price. But I had a hard time understanding what does the black line means.
I think the black line is the market, the pool status of this range. So in this green area, this black line is at the upper price of this range. And because this range is out of range, because the upper price PCU is lower than external price. So this range is out of range. And
yep.
Just like Uniswap V3, if the external price is here and you are out of range, the upper price is lower than external price, right? So all the token in this range will be USD, right?
Yes.
So this is them in this green area because the upper price is lower than external price. And AMM price normally will be around external price. So it's out of range. And all the tokens in this range will be USD. But with the external price growing and the PCU growing more faster, it will become in the range at this point, right?
Yeah.
So between this range between this external price range, the AMM range will be in the range, right? Because it's in the range, and the market price will usually people will trade around market price. So the AMM price will around market price, like this line. So this dashed line is still the PECU, the upper price, and this is lower price. So within this range, people will trade at around this price. So within this range, the tokens in the pool are USD and ETH, both USD and ETH. And since the lower price also growing more faster, so at P app, the lower price will starting to be equal to external price at this point. So as Uniswap V3 showed, if external price is lower, than this lower price, all your tokens will be ETH, right? And this is the same as we come to P up. As the external price comes to P up, the lower price will be equal to external price. So all the tokens in this range will be ETH. And if POs continue growing, this range will starting to be out of range again, because the PCD is greater than PO.
So it sounds like it is like Uniswap V3, but your range actually moves automatically depending on the external price.
Yeah. Your range
yes.
price will automatically change with external price, and the speed is greater than external price changing speed.
Yeah.
Yeah.
But what would happen if because when in Uniswap V3, if you move your liquidity, the spot price does not change. So if you try to move your liquidity and that liquidity overlap with the spot price, you have to change the amount of base token and core token that you put into your liquidity. I was wondering, how does that work in this AMM? Because now everything is automatic. How does it handle that rebalance inside it?
So I think there isn't rebalance because the market price of this AMM also changes. Let's assume this red line is the market price. So the market price of this AMM also will changing with external price. So users don't need to remove and re-add the liquidity or rebalance their liquidity. It all done by the protocol. So you don't need to do anything. And I'll explain a little bit later about how it works.
But let me make sure. So you are saying that the market price of this AMM actually changes without any swap, right?
Yeah.
Okay, got it.
Without any swap, if the external price changes, the market price will be changed.
Got it.
And
okay.
It's more faster. So this is what I say. They intentionally create an arbitrage opportunity because if, let's say, in the beginning, in this AMM Llama, market price equals to external price. So there isn't any arbitrage opportunity. And if external price increase, market price also increase without any swap. It will increase automatically and will be greater than external price. So there will be an arbitrage opportunity.
So it's like they are intentionally pricing their asset higher or lower to create like a discount or premium, depending on whether they want to buy or sell the asset.
Yeah.
So it's almost like a continuous liquidation process inside the range.
They create this arbitrage opportunity to liquidate or converting the collateral. Yeah. The purpose is to convert the collateral or convert back the collateral.
Got it. So your cost of doing so is actually how much discount or premium you are willing to add to your pricing. So if
Yeah.
the red line is the angle between the red line and the blue line is higher, that means you are willing to pay more to incentivize people to trade with you.
Yeah.
Okay.
So if the price diff is higher, you will be the loss of the pool will be higher because there'll still be impermanent loss because of the price diff.
Yeah, because of the price difference. But people will also more likely to trade with you because of that price difference.
Yeah. All right, let's move on to next chapter. The MM formulas. I will not go too deep about the formulas. You can check if you're interested. You can check the white paper. The first I want to mention is that Llama also Llama needs external price. So PO here is external price. Unlike Uniswap v3, Uniswap v3 didn't rely on external prices. And Llama invariant is just like Uniswap v3. You can see this invariant is very similar to Uniswap v3, right? But in this formula, I, F, and G are all functions. They're not constant. They're functions of PO. So they're all changing. So I will be changing, F will be changing, G will be changing. And XY is the user's token balance, or the range, or the token balance of the range. So X normally means USD, and Y means ETH. So the pool price, and we can assume F and G is the virtual token similar to Uniswap v3. And the pool price will be X at F divided by Y at G. This is the pool price. And since the F and G are functions of PO, so F and G will automatically changing if the PO changes. So the pool price will change with external price change. And there's a P up and P down. That means the bands on external price domain. So Llama split the external price domain into multiple ranges called bands, just like I showed before. There are 3 bands. So in Llama, actually there are many bands and connected with each other. And each band there will be a P up and a P down, which means when the price hits P up, someone's collateral will be starting to be liquidated. And when the price hit P down, all the collaterals will be liquidated. And the band price sequence is a geometric progression. So the P up divided by P down is at a constant ratio, and A is a constant. So this is how they split the external price domain. And Llama.
So no one can change the constant?
There is only constant called A that is created when contract being deployed. Yeah. And so F and G are all variables. Also, I is variable. They're all functions of PO.
Got it. Thanks.
So the contract deployer will decide the A. I think in their code, A equals to 100. So P down divided by P up is like 99 divided by 100. It's similar to Uniswap ticks, right? But These prices are on external price domain, not market price. Any other questions? All right, let's move on. So as I mentioned, F and G are functions of PO. If we set a value, all the bands P up and P down will be a constant number. Yeah. And there's another variable in this function called Y0. Y0 is the collateral amount when AMM and external price is equal to P up. So in this chart, I think, when the AMM price and external price is equal to P up, like this, all your tokens in the range will be ETH. So this ETH amount is Y0, equals to Y0. So we can think Y0 as a constant here. The only variable in this function is PO and PO. So with PO increasing, F will also increasing and increasing exponentially because this is squared PO. And with PO increasing, G will be decreasing, right? So let's look at the price, how the price will change with external price. So with external price, let's say external price going up, so F will also going up and G will be decreasing. So this market price will also increasing, right? And increasing with the faster speed. So this is how they change the AMM price. So you don't need to rebalance, remove, or re-adding your liquidity like Uniswap v3. You don't need to do anything. The AMM price will automatically change with external price. This also applies to the range price, as we mentioned, PCD and PCU. The range price also growing and dropping with a faster speed. So I will not go into too much detail about this. You can check at the white paper. So actually, PCD and PCU formula is here. You can see that with PO increasing, PCD is also increasing and more faster, and PCU also increasing more faster. And I want to show some charts of this. How does the AMM price changes? And in this chart, we have two bands. And in the first band, this is the P down, and this is the P up. And in the second band, this is the P down, and this is the P up. And let's see how the market price will changing. The red line is the market price of the AMM. So if someone swap on the AMM, the market price will changing, and this A value is the X amount in this AMM. So if someone swap in this AMM, market price will be changing. But if no one swap in this AMM, but the market price is changing, this AMM price also will be changing. Let's assume that this orange line means this blue dashed line means AMM price equals to external price. And let's move on to a point that AMM price equals to the external price. Maybe at this point. So at this point, in the red line is the AMM price, which is equal to external price. So there isn't any arbitrage opportunity. But if the external price increasing, sorry, I'll jump a little bit. So we started from here. Market price equals to external price, right? And the x-axis is the external price. So with external price increasing, the market price increased more faster than this blue line, right? And if the market price, if the external price increasing a little bit, let's see how market price goes. All right. We started from here. External price equals to market price. But if external price moves here, the market price will be here. So at this point, market price would be greater than external price, right? So there will be an arbitrage opportunity for arbitrageurs. Since the ETH price in this AMM is higher, they will sell ETH to the AMM. So the ETH reserves in this range will increase. So they will sell, let's say they sell ETH to this AMM. So the USD amount in this AMM will decrease, like this, decreasing, because they're selling ETH to it. And when they're selling ETH to it, the market price goes down. And now we reach to this point, market price is equal to external price again. So with arbitrageurs, they actually sell ETH to the pool. And you can see if the price continues go up, price continue going up, going to the P up. And we will have a arbitrage opportunity again, because last time we reached this point and the external price continues going up to here. So market price will be here. And so market price is greater than external price again. So arbitrageurs will continue to selling ETH to it so that the market price will decrease. So arbitrager continue to selling ETH to the pool. So the USD amount in the pool will decreasing. And the market price going down. And the market price equal to external price again. And you can see in this pool, the USD amount is 0. So no more USD in this range. And it is at the lower price of the range. So at the lower price of the range, there's 0 USD 0, and ETH, all ETH. Let's say maybe 10 ETH. And if the price, let's say the price decreasing, price decreasing means liquidation will happen. So we started from here and Oracle price decreased to here. So the market price is at here. The market price will be lower than external price. So arbitrageurs will buy ETH from the pool. So ETH will be converted to USD through arbitrageurs. Arbitrageurs will push back the market price to the same level as external price. So arbitrageurs actually buy ETH, so they'll send their USD to the pool. So the USD amount in the pool will increasing at this point. So at this point, market price will be equal to external price again. And the USD amount in the pool increased, but the ETH amount in the pool decreased. And if the external price continue going down, let's say going down to the P down, and it will happen again. Arbitrageurs will, with the market price lower than external price. External price is here. So arbitrageurs will buy ETH from the pool. And at this point, all the pool reserves will be USD. So ETH reserves will be 0 and all in USD. Let's say there's a 1,000 USD. So this is how they change the market price and range prices of the AMM. And they have multiple bands in this external price domain. I only draw 2. And if the price went here, so this is the P up of the first band. Let's say price goes to here. And if the price continue going up, external price continue going up, that means the range of the first band is out of range, right? Because the PCU is greater than external price. It would be out of range. Normally, it would be out of range because people only trade around external price. But there will be a second range of the band 2, like the purple line. So people will trade in the second range, the purple line. This is the PCU of the second range and PCD of the second range. And there's another red line. This is the second range, the market price of the second range. So it's basically the same as the first range. All right, this is how they change their market price and range price to liquidate users' collateral. I just showed this chart. Is there any questions so far? G2.
When people trade with your AMM, does that change the AMM's price?
Yeah, change. They will change the AMM price, but we can assume that people will trade to that the market price would be similar to would be around market price would be equal to external price. So you can still change. You can still trade in this AMM. If you trade in this AMM, market price will goes up or goes down. But in the long time, the market price will be similar to external price, just like other AMMs.
Due to how does that happen in this case? Is that because okay, there are 2 things I want to know. The first thing is you say that trading will change the AMM's price.
Yeah.
Is that changing in the same direction like a normal Uniswap?
Yeah,
AMM?
just like normal Uniswap AMM.
So if people are selling you ETH, it actually your AMM price will go down.
Yeah.
So in that case, well, does that mean it's going further and further away from the external price?
Let's say the external price is here and the market price is now at here. So people will sell it in this AMM. So
yes.
So the market price will goes down. Let's say people sell ETH. And when people sell ETH, the USD amount in the pool will decreasing.
Yes.
So it will decreasing. The market price starting went down. So the market price goes down.
Oh.
So if the market price goes down to here, the market price will be equal to external price. But people can still selling ETH to it. Yeah, people can trade as arbitrarily. There's no limit. You can still sell it to this AMM, but you won't have a profit selling to this AMM because the price is equal to external price. But you can still do it. If you sell it, the market price still goes down to here. And if you're still selling ETH to it, the market price will be lower than external price, and some arbitrageurs will push the market price back.
Yeah.
Right? Yeah. So it's just like a normal AMM.
So the effect of selling or buying ETH from the AMM is basically moving the red line up or down.
Yeah.
Okay. Okay, got it. Thanks.
And I want to mention is that users collateral, when users collateral starting to be converted to stablecoin, that means the user's range is in the range. And that also means user is in liquidation mode because his collateral will be starting to be converted to stablecoin. Normally, this is not what we want happen when we borrowing stablecoins. And if the price drop and bounce or sideways may cause some loss in the pool. This loss comes from the price difference because if the market price changes, like let's say we are here, market price equal to external price, and external price goes down to here, the market price will be lower, and arbitrageurs will buy it from here. So the average buying price may be a point between these 2 points, maybe here. So the pool is selling ETH at an unfair price. So the external price may be 1,000, but the pool is selling your ETH at maybe 950. So there will be a loss in this AMM because it will sell at a lower price and buy at a higher price. And if the price goes up, the AMM maybe will buy it at an even higher price like this. So there will be a loss, just like the impermanent loss in other AMMs. Two.
So just a quick observation. So that means this AMM is actually path dependent, right? If you go back and forth multiple times along that curve, you're actually going to keep losing value.
Yeah. It's unlike Uniswap V3. If the price goes up and down, you may not have impermanent loss. If the price goes up and goes down to the same point as you adding liquidity, you don't have any loss. But in this AMM, if the price goes up and down, you will continue losing money.
So its purpose is almost the opposite of a normal Uniswap. LP, that you don't want the price to stay around that place.
Yeah, you don't want to be in this liquidation mode.
Yeah.
So you don't want your collateral starting to be converted to stablecoin. You will have a loss. Although the other Michael says that the loss is not too much. Did some simulation. He used historical data and did some simulation. If the price drops and bounce, how much loss you will get. And I can give an example of this situation. Why it's different from Uniswap. Uniswap of the path dependence issue. Let's say if at starting point the ETH price is 1,000, and we add some liquidity to Uniswap, and if the price goes up to maybe 1,200, the pool will sell ETH to traders. So the ETH reserve will reduce. So pool is selling ETH, and maybe the selling average price is 1,100 at this price. And if the price goes back, the pool is starting to buy ETH, and the buying average price is also equals to this price. So if the price goes up and down, you don't have any loss. if the price goes up and down to the same point, you don't have any loss because the selling and buying average price is the same. But in curve, it's different. It depends on how the external price changes. If the external price changes very fast, you have a huge loss. In curve, if the price goes up to, if you add liquidity at 1,000 and the price goes up to 1,200, the pool actually buys, and maybe it buys at average price at 1,150. And if the price went back, pool will selling the ETH. And the sell price may be lower, so the pool will have a loss. And if the price goes up and down, up and down, up and down, there will be continuing losing money of the pool. All right, let's move on. This is the core part of the Curve stablecoin Llama and how the user will interact with the stablecoin. They have a factory that will deploy controller and a Llama pool for collateral. So for ETH, there will be a Llama pool and there will be a controller. They can also create another pool, maybe for CRV, so you can use CRV as collateral to borrow stablecoins. In this example, the collateral is ETH. And the factory will deploy this controller and the Llama pool. So this Llama pool is ETH and ETH with Curve stablecoin. That's called Curve USD. So this is the Llama pool.
Paco, if we deploy another Llama pool for Curve, so those are those Curve USD the same Curve USD or different Curve USD?
Same USD.
Okay, thanks.
So only one stablecoin. Let's call it Curve USD. And this stablecoin can be minted from multiple collaterals, maybe minted from ETH or minted from CRV. So there will be multiple pools, maybe one for ETH and one for CRV or one for Perp. It's all possible, yeah. And there will be controller. The controller is the admin of this pool contract, and the user interact with a stablecoin user interact with this controller. So they can create loan. Create loan means you deposit collateral and borrow stablecoin from it. And you can add more collateral or remove collateral or borrow more or repay your collateral. And maybe you'll be liquidated because there's a cost when the price goes up and down. So there may still be need liquidators liquidate some users' collaterals, but normally it won't be. You don't need liquidators because your collateral will be automatically converted to USD. But in some situations, you still need liquidators. So this is a stablecoin to interact with controller, and controller will deposit the user's collateral into this Llama pool. And if the collateral price goes down, maybe users' collateral will be starting to be liquidated. And external traders or arbitragers, they can interact with this AMM pool. They can call the exchange function to exchange tokens in this pool. Just like normal AMMs, there's no difference between normal AMMs. And there's a monetary policy that controls the borrowing rate. And I'm not going to too more details about the monitoring policy and the rate for now. This is how user interact with Llama. All right. So the factory creates this contract for collateral, and admin of Llama is the controller. And stablecoin users interact with the controller, and traders interact with the pool contract. They can trade between ETH and the Curve USD. And that's all for Llama. And the second part is the stabilizer and monetary policy. These two parts helps to stabilize the Curve USD price. Let's say this PS is the stablecoin price, the Curve USD price. If the stablecoin price is greater than 1, the pack they have some pack keepers. The pack keepers will help to lower down the price. So how this pack keeper works? They will create a lot of Curve V1 pools for Curve USD. So maybe there would be a Curve USD to DAI pool and to USDT pool and USDC pool. These are Curve V1 pools. And each pool there would be a pack keeper. If the price of the Curve USD is greater than 1, that means the supply, the Curve USD supply in the market is too much. So, that means the supply of Curve USD is not enough in the market because it's too less. People would like to buy Curve USD and causing the price greater than 1. The pack keepers will help to decrease the price. So they will mint. Let's see here. When the Curve USD pool is greater than 1, normally the V1 pools will be in balance, and Curve USD is lesser in the pool. So pack keepers can mint Curve USD from thin air, but the data will be recorded. And all the minted Curve USD can only be deposited to those Curve V1 pools. So let's say Curve USD price is currently at 1.2, and in this pool, the reserve ratio is imbalanced. Maybe there are 1,000 USDC, and there were only 500 Curve USD. So Curve USD will be a higher price, at a higher price. So at this time, pack keeper can mint Curve USD and deposit to the pool. And it is a single-side liquidity. They can add liquidity to the pool. Let's say they add 200 Curve USD to the pool. So this will help to lower down the Curve USD price. And if the price goes down, the pack keeper can withdraw from these pools and repay their debt. As I said, maybe the pack keeper minted 200 Curve USD. When the price goes down, he'll need to withdraw from the pool. He will need to withdraw 200 Curve USD and repay this debt. So the minted Curve USD can only be added to the pool or removed from the pool. And because of there are some price difference, he mints the Curve USD at a higher price and withdraw it from at a lower price. There will be some profits. And these pack keepers are called by external callers. So when the price goes down, when the Curve USD price goes up, external callers can call the pack keepers to add liquidity to the pool. And when the price goes down, the external callers can call the pack keeper contracts to withdraw liquidity. And because since there's a profit because of the price difference, and if you call this contract and you generate some profit, they will send some profit to the caller. And the profit is denominated in LP tokens. So maybe the pack keeper minted 200 curve USD and deposited into the curve pool, and he got maybe 300 LP tokens. And then when the price goes down, he withdraws 200 curve USD from pool. And that only burns 200 LP tokens. So there will be 100 LP tokens left. That is the profit of this pack keeper. And some of the profit was sent to the caller. And it's easy.
Do you know, do they mention any way to mitigate to prevent external caller to sandwich attack this transaction?
Yeah, they have a sandwich protection. Yeah, they have a sandwich protection in their code, but I can't remember the details.
Yeah. It's okay. If they have, yeah, we can take a look. Thanks.
There are some checks to prevent sandwich attack, and they need to make sure you can generate profit from the external calls. If you actually call the contract and did not generate profit, it will fail. Okay. I think this is easy when the curve USD price is greater than 1, because some other users may mint curve USD and sell to the market, so it's easy to maintain the price and lower down the price when the price is higher than 1. And when the stablecoin price is lower than 1, Curve will increase the borrowing rate to higher up the price, and they will increase the borrowing rate through this monetary policy contract. If the Curve USD price going down and is lower than 1, that means there are too much Curve USD in the market. There's a surplus of Curve USD in the market. So Curve USD is too much in the market, so we want to let users burn their Curve USD and repay their debt, so we can decrease the supply of the Curve USD in the market. That will help us to make the Curve USD price higher and keep pegged. So they use a formula to change the rate in their white paper. But so this is how they change the rate. It is a little bit complicated, but I will not go too much detail here. But in the code, I think in the code is different from this formula. And I'll just draw a chart from the formulas in the code. I'll show you how they change it. So there is a target debt ratio, and there's a pack keeper debt ratio. Pack keeper debt ratio means the debt of pack keepers. So all the pack keepers' debt, because pack keepers can mint Curve USD from thin air. They don't need collaterals. The debt from pack keepers divided by total debt. So the protocol's total debt. This is the pack keeper debt ratio. Let's say it's 10%. That means pack and the total supply of Curve USD is 1 million. Maybe the total, let's say the total supply of Curve USD is 1,000, and the pack keeper debt ratio is 10%. That means pack keepers minted 100 Curve USDs. Yeah. So this ratio will change if pack keeper mint starting to mint Curve USD. And there's another target that ratio is set by contract admin. This is the peg keeper that ratio. This is the target ratio, and this is the initial rate. And the initial rate may be 2%, the borrowing rate. And there's another constant called sigma in the code. It is set by contract admin. Yeah. So the rate will change with this formula. And the x-axis is the the Curve USD price. So you can see if the Curve USD price is greater than 1, this ratio will be very low, close to 0. The y-axis is the borrowing rate. X-axis is the stablecoin price. So with the stablecoin price greater than 1, the ratio is pretty low. So it will encourage people to mint more Curve USD to lower down the price, and the borrowing rate will be low. But if the price goes down and below 1, this rate will increase rapidly. So we will increase very fast. And maybe we change the target ratio, it will be different. And we can change this peg keeper debt ratio. Let's say the peg keeper debt ratio is 47%. In situation when the price goes down to 0.9, the rate starting to increasing rapidly. So if the price is lower than 0.9, the borrowing rate will be very high, starting to be very high. So they're starting to rising the borrowing rate rapidly. That users will have to repay their debt because the rate is too high. And it will help to decrease the supply of the Curve USD in the market, and further helps to higher up the Curve USD price in the market. And as I said, if the Curve USD price is greater than 1, the borrowing rate is super low. And this is the monetary policy. It's quite simple, I think.
I'm wondering, could you explain more about the borrowing rate? So, for example, like if 1 ETH is $1,000 and I put 1 ETH, how much can I make based on, let's say, a 10% borrowing rate?
Okay.
Or is that the wrong question?
Okay. So if you deposit 1 ETH and you borrow maybe 1,000 Curve USD, right? So your debt is 1,000. This is your debt. And your debt will increasing at borrowing rate. Let's say the borrowing rate is 2% per year. So after a year, your debt will be 1,002. So this is how they change the rate, change the debt. If the debt is 20%, after a year, your debt will be 1,020. Okay, and another detail is that the borrowing rate also will affect the P down and P up, because as I said, the P down is the liquidation and the price. So at the P down, all your ETH will be converted to USD. And as we mentioned, there's a borrowing rate that everyone's debt will increasing at this rate. So maybe we set P down at $1,000. So when ETH price goes to $1,000, all your ETH will be converted to USD. Let's say you will get 1,050 USD. And if the rate is too high, maybe 10%. So after a year, your debt maybe will be 1,100. So your debt will be greater than this USD amount. So it would be risky for the protocol in the long term because the rate, everyone's rate, because of the rate, everyone's debt is increasing. So the protocol also moves this liquidation end price and liquidation begin price. This is also P down and P up. All the price also increase with this rate. So let's say the rate is 10%. So at the starting point, the P down is 1,000. So after a year, this P down maybe become 1,100. So if the price hit this price, you will be your collateral will be fully converted to USD, and you may got, let's say for example, you may get 1,150 USD. So they can ensure that the USD amount will be greater than your debt. So there will be less risk for the protocol. So actually the P down and P up also increase with the borrowing rate to ensure the risk is lower on the protocol of the protocol. All right. So that's all. I think that's all. Is there any question?
Sorry, one more question. So how do they get the external price? Is it
They
from
use
the
Curve V2 price. I think for ETH they will use Curve V2 price, and they have a price aggregate. So they may aggregate several price sources and aggregate the external price to a price oracle. So, and they have a EMA price oracle a built-in price oracle contract that use EMA price of the external price. And they will use, I think they will not use Chainlink or something like that. They will use, so there will be Curve V2 pools for ETH. So they will use this price as the oracle price of Llama.
is it a new function or old function from previous contract?
In the previous contract, there's only a EMA price, but I think Curve add another contract in this new stablecoin project. They will aggregate more prices and calculate the EMA price of the oracle.
Thanks.
So they may calculate this EMA for this Llama pools. Any other questions?
Sorry, one more question for the L, that new AMM. What if the price drops so fast that is below the P down, but you are still all in ETH? In that case, what will happen to the AMM?
You mean price drops too fast, right?
Drops too fast, so it is actually below, for example, the band 1 lower price.
Oh, actually, it will not be below, because if all your collateral is in ETH, this red line will be same as this green line. And you can see here, it's the same speed. So the market
Right,
price.
But that's the AMM price, right?
Yeah.
But what if the external price is dropping faster?
There's
So
no.
the scenario I'm imagining is that the price drops so fast, and there is no arbitrager or liquidator that is able to trade with you before the price drop below the lower price. In that case, they might not have the incentive to trade with you anymore.
This won't happen because with the external price, as you said, external price is dropping very fast. The market price actually will dropping more faster than the external price. So the market price will be always lower than external price. Sorry, lower. So the market price will be always lower than external price, even the external price dropping very fast.
Does that still hold after the external price is lower than the lower price of your band?
Yeah, if the external price goes out of the band, let's say external price comes here.
Yeah.
Blue line. External price here. The market price in this AMM will be here. So there is still an arbitrage opportunity. So people will buy ETH and all your ETH will be converted to USD. Yeah. There's still an arbitrage opportunity.
Yeah, I guess I am just curious on whether or not they will allow you to do this, because obviously you're going to give them a really huge discount, but
Yeah.
but that is at the same time also out of the band you have set. So it pretty much become an edge case. Do you still want to sell, or at that time you rather not sell?
You have no choice. You have to sell. Yeah.
Okay, got it.
Because you cannot withdraw your liquidity. It's all controlled by the controller, so you have no choice. If the
I'm curious that whether or not this AMM has a safety feature that if the price drop below the band you have set, it will actually remove your liquidity instead of still selling it.
It actually very possible to drop out of the band, because actually the band ratio is very small. Like I said, the upper band and lower band ratio is like 99%. So there will be very small band. So your collateral actually will not all put in one band. You may put in 2 band or 3 band. Let's say you put your collateral in 3 band. You will be starting to liquidate at this price and liquidate at this price. So the end liquidation price is the lowest range price of the lower band, and the starting liquidation price is the highest price of the highest band. So you can deposit into multiple bands. So the price range would be wide, I think. So,
but that is not a guarantee. Even though you have 3 bands, that does not mean that the price will not move so fast that it just penetrate all 3 of them in one transaction. And in that case, I guess it's just a question of, do you still want to sell it even though the price is much worse than what you have said?
Yeah, but you have no choice. You have to sell because you are in liquidation mode. Your collateral have to be sold to USD.
So I guess in that case, you will just sell it based on the dash line.
No,
basically the projection of your last band, I guess.
If the price goes out of your band, you still have to sell at very low price because your market price was still going down.
Okay.
More faster at this price. So the average selling price may be at this point, so it's lower than external price. But I think this will be a very rare case for ETH as collateral. If they choose a legit coin as collateral, maybe ETH or CRV. And Michael said he did some simulation on his historical ETH price changes. So the loss is not too much actually. And
虽然现在在录影，但应该可以用中文了。
哦
，OK，
我结束一下。 Rain 可以帮我结束一下吗？我怎么结束？
好，